Hey everybody, welcome back to the show. As you can see behind me, we are just about out of sun. Again, have another day behind us. And I spent another nice fall day just disassembling this Diesel 40 parts cat. Old Frosty here. We got all the gearing out of him today, and boy, we've been finding some good stuff. But that means I don't have any fresh RD6 footage for you all. So, well, we'll fall back on some video files that have been living on my camera since, mid last summer. All right, back into the shop. The topic of today's episode is this beautiful Eisemann Magneto that Senior rebuilt last summer. This is a model CM-4, used on a lot of the gas Caterpillar tractors of the mid to late 1930s. Now, we've been in the shop a bit working on these adapters recently. People have noticed this in the background, and I've had several comments, like the one left by Steve Belzer here. Is there a story behind the Eisemann on the bench? It looks amazing. Yes, there is a story on this Magneto. Senior completely restored this one last summer at the same time that he was going through the Eisemann CM-4 that was on the little Catch-22 1936 Caterpillar 22 that I purchased at auction. He had to do some tuning on that one for us to make that run, and as long as he was in the Eisemann CM-4 mode, this was a solid core that we picked up at a swap meet. He took this one apart as well. It received some new old stock pieces. Like I say, he went completely through it, front to back, top to bottom. And he also filmed a good majority of that. And as I said a minute ago, those files have been living on the camera ever since mid last summer. I told him when I had a gap in the feed and time to throw that together, I would. I didn't think it would take me this long, but I finally compiled it. So this Magneto work is not for the faint of heart. It isn't difficult, but it's very detail oriented. It's time consuming, and you either do it all or you don't do any. He's made this one into a really hot mag. It is amazing how well this works at the end of the episode when he does the demonstrations. So, all right, sit back, relax, grab some popcorn, and I'll hand it all off to Senior.
Squatch Senior back with you guys here. Not sure if you guys have been following Squatch 253's channel here, but recently we picked up a Cat 22 gasser that we've been kind of working on in our spare time. We've got everything almost ready to go, checked for spark, and we had no spark. So we took the Magneto off and brought it into the shop, and I'll show you what we did here. Okay, here's the Magneto. It's a Eisemann CM4. There is also a CM or CT4, as you can see here. The difference is CT4 has an external magnet around the inside, and we go back to the CM4 and the magnet is in the rotor. So anyway, we're dealing with the CM4. Magneto's got the special coupling cover that's used on Caterpillar engines right there. So anyway, what we did, first thing we did was took the top cover off and started looking at points. Squatch had tried to clean the points. It didn't do any good and anything else. So first thing I did was isolated the condenser and the coil. I give them a test with my Wyco coil and condenser tester. I found out that the condenser was good at 22.22 microfarads, and the coil had good spark. So next thing was I took the points out totally and cleaned them, and the best way to clean them was with a stone. They recommend no filing and no sandpaper in them because it could create fine scratches on the surface and cause arcing and stuff. And now there is two different types of points in here too. One's titanium, and I can't remember what the other one is. I got the books over here telling me all that. So anyway, I'll take you over to the bench and show you how I clean the point surfaces up. Okay, here I am, set up a device. I've got a stationary contact out of a CM-4 right here, and I'll demonstrate how to clean that surface up. This one does not look too bad, but we'll touch her up regardless as long as I got them apart. So what I do, I use a stone. I use the fine side of that, and what I'll do is carefully make sure I stay just as square as possible and just go right across the contact surface. You just keep working her down until you get a nice square contact surface all the way across the whole face of that contact. So anyway, you just keep working that down, and you can see it's starting to shine up pretty good. I don't know if you'll catch this in the camera or not, but you can start seeing it's getting a little shinier and stuff. So that's the way I go about it. So far it's been working good for me, and that is the recommended procedure according to the book. Back here at the bench again, got everything back together, got the points adjusted to 20 thousandths. Everything where it's supposed to be. Took her over to the bench, hooked up 4 plugs, started turning her over, and we had spark. So basically, I think our main problem was just dirty points, which a lot of times just cleaning these things up good makes all the difference in the world. And I think some of you guys have noticed another project going on here in the background. I do have another CM-4 I've been working on back here. Got everything pretty well cleaned up. I didn't show taking it apart. Taking stuff apart's easy. It's getting it back together where the problem is. So I'll see if I can maybe get this thing back together, kind of show you guys some of the things I have to do with her. And here's your magnet inside the rotor. And I do have, believe it or not, 2 broken off screws. Got one here in the cover, and I got one over on this side that holds one of the vents on. So that'll be a project I got to do. This thing was in pretty tough looking shape. You can see I am missing one Eisemann tag on the side. Here it is, I took it off. She was pretty well corroded and stuff. So what I do to clean this up, I take it in the sandblaster cabinet. I got kind of a coarse black blast, pretty well wore out stuff. I'll take initially blast everything down with that, and then I have a bead blaster cabinet with 80 grit bead that I go through, and then I'll polish everything up. Top comer come out pretty good. Somebody had been on top and scratched all kinds of scratches in it. I took a file, kind of worked her down, got the scratches out, took the first initial blast and kind of cleaned her up. Then I took the beads and kind of cleaned her up after that, and I think this stuff turned out pretty good. So anyway, I think we have the Cat 22 mag problem solved. All we got to do is get that on and see if we can get that thing going, and we will get into this other CM4 here, getting that back together. So got the mag housing set up in the Bridgeport here. I did get everything centered up really good. Got a 4-flute end mill, about an 1/8 inch in there. I'm going to start doing my first pass through. It looks like I'm really centered in there. And you know, sometimes what I have to do, I got to put a helicoil insert, which has been working good. That's a 1032 screw, and I've got the 1032 kit. I got all the taps and die set that I picked up at a swap meet. I thought pretty good price, $25. And it's been indispensable. Had this for quite a few years. So let's get this drilled out and see how centered I am. Just doing this one-handed here. We'll see. And she is really cutting in there good. All I got to do is break that off in there, and that will really make my day. Taking her slow, don't want to force that small end mill. Well, I know I made it through. I can start to see a little bit of aluminum come up here, so I'll get that vacuumed out, and I don't know if I want to change my setting. I'm going to see what I got going there, and then I'll probably just do a drill bit to make her a little bigger. quit complaining. Okay, we got it drilled out. It's hard to see here with the camera, but I'm starting to see threads, a little bit of thread all the way around. Might have went a little too far, I don't know, but I still have other options with the helicoil. So I'll run a tap through that and see if we can salvage it yet or not. Got it all tapped out, cleaned out everything else, doing a test fit right now. I got the screws in, we'll just do it against the cover. That's a good one, I got that one tight. We'll get down here into this one. Tighten her down. Yep, I like it. Salvage that one. So now that you've seen how I go about doing this, I'll get this one out. Got this one out, and very good success. Actually, I was really centered on that one when I took the number 29 drill bit, which is the size for 832. That's a fine thread. I could see threads just barely all the way around. Run the tap through, cleaned up excellent. Put the screw in, tightened down the way it should. So there, success on both of them. Didn't have to use any helicoils. So next step, I'll go through, I'll run a tap, clean up all these holes. When I did this one here, I noticed here, it kind of migrated in from the back side. Because you can see here, where it is right in there, that was packed full of that white crusty stuff. I couldn't even get the tap all the way in. I had to take the drill bit, drill her down, so I get the tap in to finish threading that one out. So yeah, things turned out really good. I'm really happy with it. Okay, did the final clean. Got all the holes cleaned out stuff. And I did find some blasting media in some of them, so it's a good thing to really get in there and clean them out. Everything's no broken off studs. I had to do no inserts and stuff. One thing that's kind of interesting, right here is where they cast around the pole shoes here. I'm missing one of these, I call them Welsh plugs or soft plugs, but yeah, you get one of them and just punch that back in there. You can see where they kind of peened it over. So I'm ready to put the armature in, rotor in. Got the bearings all packed. Everything cleaned up really nice. And I do use, it's called an electric motor grease. It's kind of for bearings. Takes heat real good without running out of the bearing and stuff. So that's what I've been using, having good luck with it. These bearings, pretty easy to do. They just snap on the race. See if I can do it one-handed here. Might have to stand her up an end. There we go, just like that. So, ready to put things together here. Okay, we'll see how things go here. Magnets have a tendency to catch on the pole shoes, so sometimes. Okay, I feel like I'm seated in there. And you'll notice here, we have in this cap here a little oil hole. It goes down, comes out there, and it comes into here, and it comes out down inside there into that oil wick. And that just wicks oil in through here and just keeps probably the seal lubricated, those kinds of stuff. So this can really only go in one way, like that. I'll get some screws in. See if we have to spin it to line it up a little more, or if we got her. Looks like I guessed right the first time. See if she turns. Oh, nice. End play. Don't really feel any. Nice roll to her. Yeah, the magnet's catching, boy. I don't know if you can see. It kind of pulls her right in. So, yep. So far, so good. Before I put the distributor gear and breaker cam double bearing assembly in. I am going to just temporarily set the breaker plate in there. What that does, it goes in the back side here. That's where your points and everything go. And this bearing butts up against the plate, which that will give me the depth of what this goes in the bore. The breaker plate's installed. We'll snug her down. One other thing I should mention, when this goes in, there's a notch in the outer race of that bearing, and that has got to be up. There is a screw that goes down through here and goes into there, which keeps the bearing into the breaker plate, and it keeps this whole assembly from migrating out. So there's another thing, make sure that notch is lined up with that hole. Here's a screw that holds that double row bearing in there. We'll get that put in. Before I do my final set on that, I'm going to get my points and everything put in and stake that in position. What they do is they just take a punch and stake a little bit into the slot for the screwdriver to keep that from coming out. And for the top, screw a little cap with a copper gasket. And we'll finish that up when we get everything else set in there. Probably one of the last steps I'll do. Next up, the pinion gear goes on. First thing you do, there is a spacer that goes in first. That goes right in there. Bottom's out against the bearing. And then find our timing indicators. There's our mark on the distributor gear. There is a mark on the pinion gear. We just put that on. They're going pretty square. Get that little tap. Okay, looks like I'm fully meshed. What I gotta do now is line up my keyways. And it's got a double key, little flat keys. I'll get them set in there. And then next up, then this goes over with a nut on top of that. So I'll get all that done off camera, but got to make sure them your timing marks are lined up. Let's do a rotation, make sure we're on. I don't know if you can pick it out, but we're right on the money there. Got everything in position. Got everything tightened down. Got the cotter pin in there. It's kind of an interesting. This is a 1-to-4 ratio here. And you can see here's the lines. With this plate on, you can't see your marks. That's why you got to make sure this is all timed before you put this together here. But a 1-to-4, one easy way to test that, you can see how the cotter pin goes there. We'll just turn that one turn. The magnets kind of lock it in right there. Quarter turn, another turn, or half turn, another turn, 3/4 turn. And next time the magnets lock, we're right on timing mark. So I'm going to start. I'm going to take the breaker plate off. That's a whole lot easier to put them breakers, the movable contact in. There's a double spring setup in there that's really stiff, and trying to get that all together with this thing in there is impossible. So we'll take that out. We'll get all the contacts set in there. And another thing I think I'm going to knock off for tonight, kind of had a few minutes today to work on it, and a lot of times I'll just set the coil in there, make a continuous circuit there for the magnets. So they say these magnets are pretty good, but we'll do that to maintain the magnetism in them. So okay, we'll pick up on this again tomorrow. Next up, we'll get the points installed in the breaker plate here. We'll see if we can get this accomplished. Remember now, I'm working with 2 different eye prescriptions with cataract surgery here. So first thing I did is I loosened that screw. And you got a kind of a helper leaf there. I'll get them lined up and get them started. Come on here. There we go. Now we'll just barely start this screw into this one. This is where it's really important to have good sharp screwdrivers. Okay. I could mount the breaker on the post and then try and get this screw started. I have probably a 99% chance of that screw flying out of there against the spring tension and never finding it again. So that's why I like to loosen this one. We'll kind of just get everything swiveled around here. Make sure all these extra leaves stay lined up. Get around. With everything loose, it'll pivot and it'll slide right in like that. Then we go ahead and tighten the screws up. Got the other one right here. Make sure all the leaves, internal leaves, are lined up. Good spring tension. Now we got the little flat washer goes on top. And all they had, this is the one I took out, which I've seen, all it is like a little piece of wire. I've seen them do an S, or I've got a brand new one. Get a little eye on it. Then you get that in, there's a little hole right there. There she goes. Then you just bend the loose end around, keep it coming up. Looking good there. And then what I'll do now, got some cam lube I put on the back side of here. They do have a felt in there for lubrication too. So next up, get this installed in the housing. This is a whole lot easier with the coil out, or as the book calls it, the winding. And then you'll have the timing marks right there. We'll line them up. We'll get the screws in, tighten her down. Next up, we'll install the stationary contact and then drop it down inside. You always got to do a few of them. Snap it in. This is the plate that goes to the condenser. The hold down screw. We'll just snug that down. Points in just to 20 thousandths. Another thing I like to do is I'll do a continuity test to make sure I got good point contact. So I'll just get my tester hooked up, one to ground, push into the stationary. Okay, there it breaks, no contact. And here we go, got contact. No contact, contact. No contact, contact. So, tells me the points are good and clean. Next up, we're going to set what I call the edge gap, or at least we're going to check it. It's supposed to be between 4 and 5 millimeters. I did do a bunch of checking in case you guys want to really check this out. They do recommend a 4.5 millimeter bit or a number 16 bit and or an 11/64 inch bit. any one of them three will put you halfway in between 4 and 5 millimeters. So I got all the different sizes here if you're interested in looking at that. But right here, any of them three sizes will work for you. And to check that, rotation on the trip is clockwise. I've got my own meter hooked up to the points to see when the brakes and when the breakers should break. As what you do is you turn this opposite rotation, lock your bit into the housing, and when it comes back and locks in, and right there, if I just bump it a little bit, breaks it. See, it's right there. So that tells me that my marks on this are right on. Now, if that was off, what you would do not touch the points, leave them 20 thousandths, and you loosen the breaker plate screws, and you can see the breaker plate is slotted. You turn that breaker plate whatever way it's necessary to get your leg set up just right, your edge gap. So anyway, this one's right on. We're not going any farther with this one. That's good, I like that. Makes life easy. A couple more things I should mention is I did use the 11/64" drill bit to lock the rotating magnet against the pole shoe in here. And another thing is isolate the condenser and coil from the points. That way you'll get an accurate reading. Otherwise you're going to get a resistance reading through any of the other stuff on there. So I always check that before I hook up the condenser or the coil. Next up, we'll put the ventilator plate in. That goes on top of the rotor and underneath the coil. Get that in position. And my handy dandy little screw starter there, indispensable when you're getting down in the corners like that. Next up, do the condenser in the coil. Condenser's got a couple little tabs there that fit right over that. So we'll get them installed and get back with you. Next up, we'll install the distributor rotor. I bet you guys have never seen a rotor look like that before. And what it does, you got a contact here. You have continuity from here to this plate here. It touches on a little tab right here that the coil hooks up to. So when the coil gets ready to fire, it sends your spark through here to the rotor, and that will correspond to whatever cylinder you want to fire at that time. Held on with 3 screws. Got to be really careful putting that in because it just screws into this fiber gear here. So I'll get that installed. Next up, we'll get the gear cover on. And this is the one where the screw broke off down there, right there. 1032 by 1.5 inches. We'll just stick a modern one in for now. It'll work until I can find a replacement for this. May have to go to my mag supplier and see what he's got. Says he's got some Eisemann stuff. So next up, we'll set that bearing lock screw underneath the cap. And when you time this to the engine inside, I don't know if you can catch it, there's a little pointer right there that lines up with the indicator on the housing. That's got to be lined up when you adjust this to the engine. Next up, we'll install a cap. Inside doesn't look too bad, probably serviceable. Brushes look good and stuff, but the outside is a disaster. Almost looks like it's been through a fire to me. I think it would work if a guy cleaned it up, get all the mud daub and nest out of it and stuff, but I do have another option. About a year ago, it was Mag Supplier's place, and he had a new old stock cap right on hand, gasket, brushes, everything in it. So this is when it'll go on. Okay, got everything together enough for a test. I didn't put the trip on, I just got a gear off a D2 mag. One thing about Eisemann, they all use the same taper back here so you can interchange. This thing, if everything is adjusted right, if your edge gap, your points, condenser tests out, coil tests out, this thing should spark without giving it a full spin. So I'm just going to do quarter turns at a time. We'll see what our cobbled together mess will do here. So here we go. You can feel the magnets in here. See if we can find the... Okay, I got one sparking over here. I'm just doing back and forth. You can see how much I'm turning that on the gear.
Yeah,
Okay.
pretty good spark on this one down here.
Let's
So
go to
now,
the next one.
yeah, on the other side, I hear some snapping over here. Right here.
Okay, see another quarter turn.
Yep, good blue spark there.
Okay. Now we'll do another quarter turn.
Now we're hot on this one.
Okay,
Yep.
now we should be back over here. This should be number 1. That one should spark next.
Yep.
So yeah, everything is working good, just the way it should. Like I say, this thing here, if everything is adjusted right, clean, connections are clean, everything tests out good, contacts on your cap are good, that's all it takes. It's just kind of a...
Just pop it past those
just
magnets.
pop it and you should get a nice blue spark.
Yep.
Tells me that's a good working mag, so we'll get together. We're going to put trip mechanism back together, top on, vents in, stuff like that. A lot of that I'll probably do after, probably off camera, I'm thinking. That's pretty self-explanatory there. So there's all the pieces I have left to put on. Got all the new gaskets made. Had to make a few new screens for underneath the vents. You can kind of see this one's kind of really hatched up and stuff. So this one's original. I'll probably use one original. Then I made some new screens for this. I made some new gaskets. New gasket for the cover. New gasket for the back end here. So, and then one thing I was going to show you guys what bad screwdrivers do. Yeah, you talk about having an issue getting these out of there. We'll get back a little bit. Get a couple more. Yeah, I had punches and chisel. I had to loosen them. Because one thing they do is, when you get them tight, you'll have slots in this trip plate. Then you peen part of the screw into that slot to keep them from coming loose. I did have another mag out there that I had some pretty good screws in, and they really came out nice with a really good sharp screwdriver that fit that slot tight. So I can't express enough good sharp screwdrivers for this. So let's finish putting this thing together, and after we get her done, we'll see what it all looks like. Well, here's a finished product. I think it turned out pretty nice. Eisemann CM-4. Fits, at least I know, a Model 22 gas cat, and I'm sure others. Has a complete drive mechanism with it. Special Caterpillar drive hub that goes on the back. Only Caterpillar uses that. Back here, some of the parts I replaced. The cap. Had some better looking vent covers. Made some screens, gaskets. And I wish I could find an Eisemann tag for the back side there, but that one's pretty crusty, so I took it right off. So hopefully this helped you guys into maybe doing your own. This is the way I do it. There might be better ways, but like I say, I firmly stress a good sharp screwdriver. And another thing that's really helpful is books. Can't get by without books. So hopefully this helps you guys out, and I thank you for watching.